This is Alexi Karve. Today I will demonstrate MicroShift running on the CentOS 9 stream. We will specifically work with MongoDB, more with the Python operator using the Kubernetes operator Pythonic framework. This will allow us to create custom resources in MongoDB, and we will be able to update a collection. So we'll see how to do that using the kopf. So let's get started. I have already deployed MicroShift on the Raspberry Pi 4. So you can see on the top screen that we have the CentOS 9 stream node. And on this, we have the required pods started. MicroShift is started. And if you look on the lower right side, you'll see that we have the CentOS 9 stream installed. I'm currently going to install MongoDB. So I will just do OC apply. So I have the MongoDB deployment, MongoDB persistent volume, and the service account. So that will allow me to install MongoDB in the default namespace. And once that is started, I'm going to run the operator locally in a development mode. So while this is creating the container, let's look at the instructions for running this. So currently I'm running these steps where I'm going to connect to the stateful dataset once it starts up. And once it is started, then I will run the Mongo admin to connect to that particular database. Once that is started, what I'm going to do is I'll run this operator in development mode as shown below. Okay, so now MongoDB is started. We are inside the pod now. And now let's connect to MongoDB. Okay, so now we are connected and we can see show DBs. We can see the databases over here. What we want to do is we want to create a custom resource that will create a database and collection, a school collection in MongoDB. So I will show you the custom resources that we are going to use. If you look at the custom resource, we are going to have the name, age, and country being written to a collection, and the types have been given over here. Okay, so name, age, and country. These are the three things that we are going to write into this particular database. So let me apply this CRD first. So the CRD is created. Now there are a couple of samples I have here. So whenever I try to enter this, it will go into the table students with this name, age, and country. Okay, so this is one of the students. And then I have a sample 2.yaml, which will put a LX2. Okay, so these are the couple of samples that I have that I want to write. So let's start the operator now in development mode. So this operator currently requires a cube underscore config. Okay, and my default variable, environment variable is kube config. So I will set this and I will set the development mode to true. And this is the actual operator code itself. So when there is a create that is called, it is going to insert a row into MongoDB. When an update is called, it will update that particular row. And when a delete is called, it will delete that row. Okay, so that is what this is going to work on. The initialize cube itself is the main function that starts this operator. So if I go to this one, it picks up the variables MongoDB host, port, username, password, and DB from the environment. And we have the dev mode. If it is the dev mode, it picks up from the cube underscore config. Okay, that is what I mentioned. So that's why I'm currently going to run in dev mode. And when I run that, I will need to have the MongoDB host, port, username, and password set. So if you look at the information over here, you can see that this is the username, password, default port that I'm going to use. And for MongoDB, this is the host. For the host IP address for that pod, I'm going to use that IP address right now. And the MongoDB database is going to be school. So let us just set these variables. Okay, so all these are set now. Now we are going to do the execution of the operator itself in development mode. So it has started now, the operator itself. What we'll do now is we will run and apply the sample. And we can see immediately, that over here, the create function was called and one of the creation was completed successfully. And over here, we can show DBs now and we'll see the school database. So we'll use school and we can do db dot students dot find. And we can find that this student was actually inserted. Let's also apply the sample2.yaml. And we can see the second create was created now. So this was the first create and this is the second create was successful. And now if we do db.students.find, you can see there are two students. Okay, one is Alex and the other is Alex2. Now what we want to do is we want to update one of the students. Okay, so what we had in sample2, we are going to change the information. So if you can see, that the country was USA, age was 24, we'll change that. And we'll change that using this. And we'll apply this new YAML file. Okay, so let's run this. And it shows that updating has been processed. Now if we look, we can see that Alex2 now has age of 26 and country of Germany instead of the previous one, which was age 24 and country was USA. Now what we'll do is that we will delete both of them. So we should see two deletes being processed. We can see deletion is processed and another deletion is processed. Both of them got deleted. And now if we look again over here, db.students.find, you can see that it is empty. So that is what this was in development mode. Now what I'm going to do is, instead of development mode, I'm going to stop this and I'm going to actually install and run the operator. So to run the operator, what I need to do is I need to apply all the files over here. So what we need is a service account and a cluster role binding. So for now, I have given this MongoDB writer as the service account, the cluster admin privileges. So this is the cluster role binding. This was the customer resource definition that we had already applied. Then we have the deployment, and this is where we are going to use the image. So to create the image, I have already created the image using the instructions that I have over here. So you can do a podman build and it will create this particular image using the Python files that we had in the current directory. And then I have pushed this image over here. So I'm just going to use this image. And in this case, what I'm doing is I'm setting the MongoDB host to MongoDB because this was the service name. I'll show you the service name again with this particular port. Instead of using a hard-coded IP address for the pod that we did right now in our development mode, I will use the MongoDB over here. And we have the root user ID and school database that we want to work with. And this is, of course, the service account. So now let's do OC apply. And we'll apply all of them. It will apply the CRD again. It won't change it. Okay, so this was already applied previously, so it didn't change that, but we definitely created the MongoDB service account and the deployment. Now, if you look at the pods, you'll see that it is creating this container. As soon as it finishes downloading this image, the container will get created. And what we'll do is we'll run the same sample again, but this time it is going to be in, I would say, a productionized kind of way instead of a development mode, because we actually have the image and the image is going to be downloaded and executed as a deployment. And this MongoDB writer operator is now going to be a deployment instead of running the Python code directly on the Raspberry Pi. So now the operator is running and we can run the sample. So if you look again, okay, there are no students in the database. And I'm going to look at the logs for the MongoDB writer operator. So you can see the authentication has finished, so it is started. And now we'll do the apply. So this is the MongoDB service that we are connecting to now. That was the name I gave. And port is 27017. That is the service we are connecting to. Let's run the sample now. You can see the first creation was completed and the first student was created. Let's create the second sample. Second creation was successful on the log above. And now we can see two students are created. Now we'll update the student like OC edit. And let's edit this student. And let's change the country to India, maybe age to 25, and we'll write it. So you can see the updating is processed. Now if we do a db.students.find, you can see the country now shows India and the age has been updated to 25 for the second student, which was Alex2. Now let's go and delete these two samples. And we can delete this. And both students have been deleted. So we can delete either using the YAML file or we can delete it directly the way we did it right now. And now if we look at db.students.find, it is empty. So this was a demonstration of using the Kubernetes operator Pythonic framework for writing an operator. In this demo, we ran it initially in the development mode and later we ran it in a productionized mode. This is all I wanted to show in this demo. Thank you for your time.